Hi everyone. I'm having to cancel class tomorrow because my son is running fever and he's sick. However, I wanted us to be on the same page for everything you need to know for the Neuro PowerPoint. Okay, I'm uploading a video today that will go over action potential, which explains how a neuron sends a charge and communicates with other neurons. So you will be responsible for that. But let's talk about the other things I want you to be able to know. I want you to be able to label the lobes of the brain. I will upload onto your Canvas a sample labeling picture that you can practice on at home. I want you to be able to match certain structures that we talked about, for example, Broca's area, Wernicke's area, the motor strip, to their specific functions. I will also upload an example of that to Canvas so that you can practice that at home. I want you to understand the action potential of a neuron and be able to explain that and put the steps in order. And then I want you to briefly be able to talk about the pathway that goes through the brain for speech production. Okay. We are not going to be covering the measurement systems for the Neuro PowerPoint. We just won't have time, and I don't think that that's fair if we don't get to lecture on it to test you on that. So on your PowerPoint, you have a slide talking about CT scans, talking about MRIs, talking about cognitive test, and I want you to omit that from your notes. Okay? Along with the matching the structures to their functions, that's when we're going to get into the few disorders that we talked about. So for example, we talked about with Parkinson's, the specific structure that's affected is the basal ganglia. So just be familiar with what structures of the brain are impacted by those different diseases that we talked about. Let's quickly go through the pathway of speech production, just so that we're all on the same page. So we talked about in the brain, we have 4 different lobes. We have our frontal lobe, we have our parietal lobe, we have our occipital lobe, and our temporal lobe. So speech production is going to start here in the motor strip, which is the large gyrus in the frontal lobe. Okay, this is where the motor plan for all movement starts. But for speech specifically, it's going to start here in Broca's area. Broca's area is speech motor control. So be aware that Broca's area is part of the cortex. So once you get all of your thoughts together, right, you have pre-linguistic thought. That's you have a thought you want to communicate, but maybe it's not assigned words or syntax or grammar yet. So your brain is going to formulate that into language, and then it gets sent to Broca's area, where all of the motor plan for speech happens. This is where your brain is going to tell what articulators to move, how deep of a breath you have to take, all of that. So from there, the next step is it's going to send that message to the deep brain structures. So it's going to travel through these white matter tracts into the center of the brain. And we're going to imagine that this brain is transparent, and this little dotted area would be your deep brain structures. We talked about 3 in class. We talked about the thalamus, the hypothalamus, and the basal ganglia. We said that the basal ganglia regulates movement, but the thalamus directs the signal to the right part of the body. And so the signal is going to travel through the white matter tracts to the deep brain structures, and the thalamus is going to send it to the correct place. In this case, it's going to be the brainstem. Remember, this is our cerebellum in the very posterior part. So the message is going to get sent to the brainstem. And why is that important? We said the brainstem is where all of the cranial nerves leave the central nervous system. It's also where the cranial nerves decussate. That just means that they go in opposite directions. So, to the contralateral side of the body. Okay? So, the signal is going to get swapped to the contralateral side, and it's going to travel through the cranial nerves to our lips and our jaw and our soft palate, all the way down to our larynx to provide voicing. Okay? And then, you remember we said that the brainstem is just a connector to the spinal cord. Forgive my drawing. The cranial nerves are responsible for phonation, articulation, and resonation. However, there's a signal that still has to go down through the spinal nerves, and that's going to control respiration. So all of that is going to coordinate together so that we can produce clear and intelligible speech. Whenever we speak, right, we're producing a sound wave, a periodic complex wave, and obviously somebody else is going to hear that message, but we also are able to hear our own message. We hear the sound, first of all, through what's called air conduction, meaning that the sound waves travel through the air and back into our ears through our ear canal. However, when we're speaking, we also get feedback on what we say through bone conduction. Whenever our larynx is producing the sound we need to speak, and our articulators are shaping that sound, this buzzing produced by the larynx actually vibrates the soft and hard structures of our head and neck. So the larynx vibrating actually vibrates the bones in our skull. So we hear what we say both through air coming back into our ears and through the vibration of our skull bones. Both of those together are able to cause movement in the cochlea, or the organ responsible for hearing, and we'll go into greater detail when we cover hearing. And that travels through one of the cranial nerves, cranial nerve 12, and it travels into the temporal lobe of the brain. Now, we said that the temporal lobe on both the left and right sides is responsible for processing any kind of sound information. But on the left temporal lobe, we have an area called Wernicke's area, and that is specific for speech analysis, right? Not all sounds, just speech. And so what we say goes back and it travels to Wernicke's area, and our brain interprets what we say. And there's a feedback loop where that allows us to make sure that what we said was correct, that it matched what we intended to say. That same pathway is also going to happen when somebody else speaks to us. So when we have another speaker who's telling us a message, we're only going to have air conduction when it's another speaker. It's going to travel through our outer, middle, and inner ear to cranial nerve 12, which brings sensory information to the temporal lobe. And if it's speech, it's going to travel to the left temporal lobe to Wernicke's area, and our brain is going to make sense of the speech that we hear. So that's the pathway for speech production and speech perception. And keep in mind that other systems we talked about, for example, the basal ganglia, for example, the cerebellum, they're involved in the regulation of motor movement. So they're going to make sure that the movement is not too fast. They're going to make sure that we're using the right amount of force for those articulator movements. However, they're only indirectly involved. It's going to be the motor strip, Broca's area, that is the direct center for speech motor control.